Alright, this video is to help you do something that's called rationalizing the denominator. Kind of an old rule of math is that we don't like to have roots in the denominator, such as over here on the right where we have 1 divided by 2 plus the square root of 3. That square root of 3 in the denominator is sort of a etiquette faux pas, if you will. It's sort of a bad thing in mathematics. We don't like to have that root in the denominator. Okay? The same thing goes for 9 over 20 underneath this root, because technically, remember that when we take 9 over 20, this is really the same thing as the square root of 9, which would be easy to deal with, divided by the square root of 20. Well, in order to deal with those, the first one's not such a bad thing. Number one thing we'd want to do is say, well, hey, the square root of 20 is a fairly large number. The square root of 9, pretty easy to deal with. Again, square root of 9 is just going to be 3. But the square root of 20, we're going to need to break down. So we can call that a 4 and a 5. Break down the 4, again, into a couple of 2's. And remember, we're looking for pairs of numbers. So those 2's and that 5 are the leaves of our tree. But a couple of numbers mean that this is really 2, the square root of 5. And to get rid of that square root of 5, we can just multiply it by itself. Again, much like we multiply fractions top and bottom much of the time to make a common denominator, we can multiply the bottom by root 5 and multiply the top by root 5. And what that's going to do is say 3 root 5 on the top, and again, we don't mind that square root up top, just on the bottom. But on the bottom, square root of 5 times square root of 5 is 5, times 2 is a 10. And we've made a much better statement that now does not have a root in the denominator. Now, in order to deal with a square root that's a part of a binomial, 2 plus the square root of 3, what we're going to want to do is go ahead and use what's called the conjugate. Okay? The idea of the conjugate can help us out, because knowing what to multiply by is very important. If we just multiply by a square root of 3 on the bottom here, again, we're going to have to distribute that. Remember that technically 2 plus root 3 is a binomial. And we're going to get root 3 times root 3 is 3, but root 3 times 2 will still have a square root in it. You would still have a 2 root 3 plus 3 in the denominator, and that doesn't really accomplish our goal. So, what we need to do is remember what a conjugate is. And the conjugate essentially is when you have a plus b and a minus b multiplied together. It's having a binomial and sort of a partner to it, but notice the middle sign is changed, such as a plus root b and a minus root b up here at the top. The important part is if we multiply those together, we FOIL that out. Again, a times a is going to be a squared. You're going to have an a minus root b on the outside and an a plus root b on the inside, which means these two middle terms essentially are going to just cancel away. And then finally, you're going to have a root b times negative root b. Don't forget the minus here. And the root, or minus the root of b squared. Well, square root of b squared, again, just becomes b. And a squared sticks around from the front. Notice what happened. No square roots remain. If we multiply a number by its conjugate, if there's a square root in one of the terms, then we end up with a binomial here without any square roots in it. Now, be careful, because many people think, oh, well, I'll just multiply it by itself, like on the previous screen. Problem is, if you multiply that by itself, notice I didn't change the sign over here. Very quickly, we can FOIL that out. The root 5 and root 5 become a 5, but notice in the middle, we didn't have a minus to work with. There was nothing negative. So we get 2 root 5's, and in the end, didn't get rid of the root. Again, the key is you can't just multiply it by just the root 5. You can't multiply it by itself, because again, the root won't disappear. We need to multiply a binomial that contains a square root by its conjugate. So, for this next example, let's go ahead and do that. If we want to get rid of that root on the bottom of 2 plus root 3, what we're going to need to do is multiply that by 2 minus the square root of 3. And again, we're going to do that same thing on the top. Now realize again that's a binomial, so all of those terms need to be surrounded by parentheses here, all those binomial quantities surrounded by parentheses. 1 times everything on the top, again, will be 2 minus the square root of 3, because you're just multiplying by 1. But on the bottom, again, 2 times 2 is 4. 2 times negative root 3 would be a negative 2 root 3. Inside, we're going to have a 2 times a root 3, so that's plus 2 root 3. And then finally, negative, right, positive and negative, so negative root 3 times root 3 is just 3, or the square root of 9, or 3. Take those terms, those two middle terms again are going to disappear. One of them was negative, one was positive. So we end up with 2 minus the square root of 3 over 4 minus 3, essentially 1, which in the end, if we're just dividing by 1, that actually made a very simple, just happened to have no denominator left on this one, statement 2 minus root 3. Let's go ahead and practice just a couple of those problems. So on the next page here, I've got a couple examples. Take a second, pause the video now, and go ahead and try these two numbers out and see if you can get the right answer. I'll bring up the correct answers here in just a minute. Okay, so if we're working on these two problems, let's start with the one on the left here. Notice there's not a binomial in the denominator. So very simply, the way to get rid of root 3 is just to multiply by itself. And we're going to do that on both the top and bottom. That's a statement that's really equal to 1, and we're really not changing any numbers. Root 3 over root 3 is just multiplying by 1. Well, square root of 3 times, or square root of 13 times square root of 13 on the bottom is 13. And 4 times root 13, can't really do anything with. So that just becomes a 4 root 13 over 13. If by chance that 4 and that 13, the 4 on the top and the 13 on the bottom, had any common factors, we could reduce our fraction as well. They did not in this one, so there was nothing to worry about. In this next example, again, if this is 8 minus root 10, again, we need to use the conjugate. So let's multiply by 8 plus root 10, both top and bottom. If we do so, again, we're going to be multiplying the two parts on the top and the two parts on the bottom. So on the bottom, you end up with 64 plus 8 root 10 minus 8 root 10. Again, those two parts, they're going to cancel away. And then a root 10 squared. On the top, you'll notice I distributed the 3. So this is just 3 times 8 was 24. 3 times root 10 is 3 root 10. On the bottom, again, that 8 root 10 and the minus 8 root 10. Those two parts were just gone. So we end up with a 64 plus, this should be a, oh, sorry, the previous step is where the issue was. Note that that was a root 10 times root 10, but we forgot the negative in here. This should be a minus sign. So we're taking 64 minus 10. On the bottom is 54. Glad we caught that. And now notice, hey, 24 and 3 have a 3 in common. I believe 3 goes into 54 as well. If you can factor it out of both the top and the bottom, as I was saying, if 4 and 13 had a common factor, we would reduce. Well, if the entire numerator has a 3 that's in common with a 3 I could take out of the bottom, then we can reduce those 3's as well, right? Get rid of that 3, get rid of this 3, and basically end up with 8 root 10 over 18. Now notice there's nothing else on the outside of the root, so I can't try to reduce again. Don't worry about the fact that 8 and 18 both have a 2 in common, or 10 and 18 would. If 10 is under the root, we can't reduce it with something that's not under the root. So there is our final answer, 8 plus root 10 over 18. I hope that helps with reducing square roots when there's a root in the denominator. Again, you now know how to simplify roots. You should know how to add or subtract with square roots. And now you know how to rationalize the denominator. Make sure that that denominator has rational numbers. Square roots of numbers are not rational numbers unless they come out nice and even. So we want to have rational, no roots in the denominator. Have a great day. If you have any questions, make sure you talk to your teacher. And of course, happy counting.